When it comes to creating the constraints for your FPGA designs, you need to remember that the critical paths are a moving target. You've written your code, simulated it, and it's time for synthesis. Now the questions are, can your design meet timing, and will it fit in an appropriately sized device? One logical approach would be to start top-down and enter some global timing constraints. Or you could start bottom-up and create constraints for the critical paths that you know will cause problems. After all, the goal is to meet timing, right? Actually, when it comes to FPGA synthesis in place and route, critical path timing is the wrong place to start. There is a whole different category of paths that you need to exclude from consideration before focusing on critical paths. The first is the false path. These are paths that cannot be activated by any combination of input vectors. In this example, the blue path is a false path because there are no input vectors that will cause the output of the red and green blocks to both activate at once. This example is a little more subtle. Again, the blue path from the output of the left flop to the input of the right flop is a false path, because there is no combination of input vectors that will cause the output of the red and green paths to activate simultaneously. The second category of paths you need to exclude from synthesis are multi-cycle paths. These include circuits that require multiple clock cycles to complete their function, such as paths with data retention controlled by adders or counters. Multi-cycle paths are very common in FPGAs implementing communication, encoding, and control functions. Think of it this way. When you design with RTL, your critical paths are a moving target, because each time you enter a constraint, synthesis will create a different gate-level implementation. But false paths and multi-cycle paths are all fixed obstacles in your way. Excluding just one false path from synthesis can significantly change where the real critical paths occur in your design. Excluding them all allows you to focus your effort on actual circuit timing and true critical paths. For more information on how to get this massive head start on timing closure for your FPGA designs, contact Blue Pearl Software.